Hello, welcome to our video about Pipeline at Computer Architecture. Today we're going to explore how Pipeline divides instructions into stages to improve a processor performance. In computer architecture, pipeline is a technique used to increase the efficiency of execution of instructions. Just like an assembly line in a factory, the pipeline divides the work into several steps, allowing multiple instructions to be processed simultaneously at different stages. This division into stages allows, while an instruction is being carried out in a stage, another can be sought at a previous stage, maximizing using a processor and increasing performance. Now let's explain the 5 stages of the MIPS pipeline. Instruction fetch, instruction decode, execution, memory access, and write back. The first stage is the if instruction fetch. Here instruction is sought from memory and loaded on processor. In the second stage I decode the structure. The instruction is searched and encoded. Operands are read from recorders and operation type is identified. The third stage is the E. At this point, an arithmetic logical unit is the least operation specified by the instruction, such as a sum or a logical operation. The fourth stage is the M, or excess memory. Uneducated requires memory access, whether for reading or writing. It happens here. We finally have the WB stage, or the execution results are written back in registers, thus completing the cycle of an instruction. Let's load a simple program into text memory that executes an instruction. For that, we also need to define the initial values. 2 recorders. The first is yes, the one of U8, 9, 10. Will be searched in the stage, and F. On stage ID, instruction is decoded. We will add the values of the recorders 10 and store the result in 8. Then, as is always save world, 8 of 7 A10 is sought in the stage. If and de-encoded in stage ID, this instruction will store the logger value 8 in memory at the address calculated from the value 10 plus the offset of a. Let's perform a DO instruction. 8, 9, 10 in the execution stage. The EULA will edit the 0x values, 2 zeros and 0x02, resulting in 0x2 at the BB stage. This result will be written to recorder 8. We will now carry out the instruction. Save world 8 out of 7 a recorder 10. In the memory stage, the value that will be stored in recorder 8, which is 0x2, stored in memory at the address calculated as 0x02, 0x01, which is 0x03. It is worth highlighting that we made a modification to the original circuit in Cornell. This modification was made to reduce the amount of null operations or bubbles while running the code, thus improving pipeline efficiency. Recapitulating, we saw how the MIPS pipeline divides processing into 5 distinct stages, increasing processor efficiency. We observe the execution of the IDEO and SW demonstrate our modification, which reduces the amount of bare operations during processing and save in memory of a pipeline MIPS. And to close, let's go to a full demo, running operations in our simulator. This code has been reordered to get the best out of the instructions and reduce execution time using lines of code as spacing, thus avoiding hazards. In addition, we use memory fork and process to pick up instruction values with which dependencies consecutive, avoiding even more bubbles. We are then left with the following instructions executed in the simulator. Thanks for watching and see you next time.